Congratulations. You've made it to the end of the semester, our mini project two, our final programming practice. And I wanted to create this video to help walk you through some of these, just the initial setup and steps that I would recommend following as you get started. First off, take a look at your grade and how you've done so far this semester. You're allowed to go back and get more points for your quizzes. You've gotten potentially some bonus points along the way, or didn't submit every program. You may already have an A, and if you do, that's great. You know, you can be done. But I think there's a lot of fun challenge associated with this. These five programming practices for this learning module 12 all have to do with using this libgd library for graphics processing. When I'm working with a new library, I want to have a few things open. Um, this is me, but this is what I would recommend for you as well. The documentation is always critical. If you have a two monitor setup, having the documentation open on one separate monitor is the way to go. Or just a separate tab of your web browser, that's fine. You always want to have that open because as you're working with a new library, as we were working with the standard C library, um, you want to understand the functions and the data structures and all the things you need to be productive with the program. A good library, and this is a good library, is going to be well documented and it will tell you how to get started with the library and even provide you with some example code for how you work with the library. You can copy and paste this and get started. Now, for your purpose of programming practice 12, you don't have to start with nothing. I did start you with an example that does some reading of files and adapted from the open source documentation example. It's where you're going to be starting from is my code that I'm providing for you. So, of course, one tab is the code itself you're working on. One tab or one screen or one window is the documentation. And if it's an open source and a well documented project like this is, I like to have the actual source code for the library open as well. If you have to look at the source code, that's a sign there's a flaw in the documentation or just a flaw in your understanding of the documentation. But it's nice to have that open. You see a function, you see what it's supposed to do, you try calling that function, it's not doing what you thought it was supposed to do. When in doubt, take a look. Look at the code. It is, in this case, it's C code. You know C code. Sometimes it takes a little while to get started and really understanding what's happening with someone else's code, but it's all there. And we have that as our kind of ground truth documentation for what the library is supposed to be doing. Now, in a more advanced maybe version of a class like this, I would spend a lot more time talking about how to work with libraries, how to download, how to configure, how to install. Because I think you'll find in modern practice, so much of software development is really linking different libraries together and getting it to work. In this case, Replit in the current incarnation is using this Nix environment where I was just able to specify, in addition to the standard packages, use that libgd package and it kind of found, compiled, linked everything in for us together. In my make file, I had to first look at the documentation, and the make file said, hey, when building this, pass these flags and it should work. So I took those flags and I copy pasted it into the make file. And when you have that, you're in pretty good shape in terms of getting started with it. And finally, it also recommends you have to bring in the library functions by including that header. I noticed that header file existed. Replit wasn't super happy in terms of trying to find the definitions and stuff. It would build, but it wouldn't give you hints and things like that if I didn't also copy it local. So I just did a local copy of this gd.h file. Modern header files are really complicated to try to support multiple platforms and to be as compatible as possible across different platforms. So there's a lot you have to read before you get to anything interesting, to be honest, with regards to that header file. It's just there for reference and to make the syntax highlighting in the IDE here a little bit nicer here. So again, libgd is a graphics processing library. It allows you to read image files in one line of code. We know how to read files, but then we'd have to understand the file formats, how to parse the individual data structure. That would be a lot of work, but we can do it in one line of code using this library. And it has a lot of functions that are there to help you transform your images in various different ways. There's a lot I can say about this. Some of it I think you'll just have to explore. But one thing to start with, as you're reading through the documentation, most of the functions you'll be using will be based in this gd.c. I would argue this is kind of a flaw in the documentation. I mean, how am I supposed to know what file are my functions in? But most of the functions we're using in this are in this gd.c, so you can take a look at that function, web page here, read the documentation. The other thing that it doesn't talk as much about in the documentation itself is kind of the data structure corresponding to the image as it's being opened. And it has a couple different views of it, but at its highest level, it's really just a two-dimensional data structure. And that makes sense, right? Because our images are two-dimensional. So we have this it's GD image pointer type that'll get returned as we see. But the end result is, and that's supposed to be a rectangle. It's close enough, right? It's a two-dimensional structure for which we have effectively, you can think of it as an array. And we have rows and we have columns corresponding to the individual pixels in our image. And I'll just draw a few of these here. Dot, dot, dot. And then, so for a certain width and a certain height of our image, we do have this conceptual view that there's this two-dimensional array of pixels associated with it, with 0, comma 0 corresponding to the upper left-hand corner and num rows, num columns corresponding to the lower right-hand corner of it. And then each individual pixel itself, and this is very common in all sorts of image processing, is going to be comprised of, in our case, a 32-bit value for which there's going to be a term corresponding to the amount of red in our image, and it'll be an 8-bit integer value for our purposes corresponding to the amount of red in that pixel, 8 bits for the amount of green, and 8 bits for the amount of blue. If you've ever done any kind of programming associated with color, RGB color is a very common approach. For one of the programming practices, you'll actually convert it to another color model, and we'll have some fun seeing different ways we can visualize the color of an image. The default storage as reading from image is stored as RGB. For our PNG files we're reading in here, the libgd library refers to them as kind of true color images, and so they're stored as 8 bits for R, 8 bits for G, 8 bits for B, and then there's actually an additional 8 bits for A or for alpha. That's for transparency information. That could be a lot of fun to work with, but we're just going to deal with RGB and kind of ignore the alpha channel if there is any in any of the images. We're working with camera images, so there isn't any real interesting alpha values that we have here. So that's the model we have to start with. And the other thing to keep in mind would be, there's a certain number of rows in our image. There's a certain number of columns in our image. We can think of our columns as corresponding maybe to an X variable, our rows corresponding to maybe a Y variable. And as we'll see, the library does provide some functions that allow you to just read image at location X, comma Y. And it's called GD get pixel or something like that. We'll see the documentation for it. It'll actually provide you a raw pointer as well. So there'll be a pointer that you can create where you can actually access that entire array of pixels. The syntax is correct, but maybe just seems a little unintuitive that, it's row first, then column. So if we called columns X and rows Y, it's fine. It would be Y, then X, right? We do our first dimension, then our second dimension from left to right in C. So if we have that model in mind, we can have a lot of fun with our images because we can write for loops to iterate through the image and mess with all of our pixels. The example that I'm going to walk you through here today is one in which we start with just our RGB image, and we're just going to want to extract out the R, the G, and the B as separate images. We're going to take out the color channels, store them as separate files, and actually just be able to visualize how much the color is in the red channel versus the blue channel versus the green channel for that image. In our markdown example here, as there is for all of these programming practices, I try to show what that means in practice. That if our input is image directory campus.png, you get the red channel, you get the green channel, and you get the blue channel. I don't want to go into too much in color theory, but the background's pretty close to white. That's why there's a lot of red, there's a lot of green, and there's a lot of blue. That's how you get white. This tree is pretty red. That's why the red channel's high, but there's not as much green and not as much blue, etc. The grass is really green. You can see how we were able to decompose this back out and do so. I can't walk through all of how I would go about doing this, but I'll step you through logically what's happening here. Another thing that's specific to our kind of automated testing environment, and I want you to take a note of this as you get started, is I wrote this function called hash image. That's takes the entire pixel array from the image and just calculates kind of a simple hash function based on it. You're not supposed to or really allowed to change that function. It is an example of how to iterate through an image, so you can look at the code and understand here's the Y and X loops, how we're doing it here. The hash function itself is kind of just arithmetic and arbitrary arithmetic to get a single 32-bit value that it then returns. And that is what gets checked in all the testing infrastructure. Input image is this PNG file. Output image is this other PNG file. And that hash function gets run on it. and your hash function result has to match what I got for my implementation for the code. This makes it doable, makes us allow us to automate the testing. I can't look at the image myself and see if it's correct or not. It may also be a little frustrating, and I want you to let me know when that happens. Like you're working on the code, your output image looks awesome. It looks exactly like I told you it's supposed to look like, but the hash function is still wrong. The hash function's kind of like a random number generator. You won't be able to look at it and know why it's wrong at all. So I want you to let me know when that happens. I want you to post. I want you to tell me, hey, my code looks pretty good, but I'm still getting a hash function. Can you come take a look? Because that could be just a simple off by one error, conceptual small error, and I just want you to get past that error. That the whole point of that isn't to deal with the hash function. It's just our method for automated testing. So visually, we want these things to look correct. To get a correct checkbox in our testing infrastructure and that whole apparatus, it has to be exactly the same byte for byte, bit for bit, pixel for pixel. So consequently, when you're off by something very small, it could just be a small gap in either the instructions or some small bug in your implementation. Let me help you get past that. It probably involves me taking a look at your code and seeing on what line number is it very slightly different than mine, and how we can get to the same result there. So let's try to break things down so that we can actually generate an images from that input image in which we are grabbing the individual R, G, and B information. First, let's just walk through the code and what it's doing. So there's the image data structure that is built into the library. There's a whole bunch of documentation on what that looks like. That would be under gd.h where it talks about that. If you actually really want to see the struct definition that is in the actual GitHub itself, and you actually see where is that image pointer, and you have to kind of scroll and you'll find it. Where is that actual structure and how it's getting defined? And it's got a whole bunch of stuff in there. It's much more than just the array, but in addition, there's also the array. Its array and metadata information associated with that image is stored in there. So we're going to be declaring those. We're going to be working with those GD image pointer types. We're also going to be doing file in, file out stuff, right? We still have to open the file just like we've been doing all semester. So open the file, read, using fopen. In this case, we're doing a prompt. We're saying, please enter the name of the file to invert. And we're doing that fopen. Uses the B flag for binary. We talked about that's not strictly necessary, but it'll work for our purposes. And we shouldn't attempt to use the library if it didn't open. That would be all sorts of seg faults. So that code probably doesn't have to change. There's also going to be a part, and we'll get to that in a second, where we actually want to output the output file for writing. And here we have to come up with what do we want the name of the output file to be. It has to be something based on our file input name. And for example, if this is campus.png, we want it to be campus underscore R, and then campus underscore G, then campus underscore B. Let's just do campus underscore R to begin with. And that would be some new file name. We can call it file out name. It may have already been declared earlier in the code. Let's make sure we're not, yeah, it's already declared. So that is already declared. We may want to then grab the dot for the PNG, because if we want to go from campus.png to campus underscore r.png, our kind of string toke approach should do that for us. So string toke, find us the location in the string where we find that first period. And that only works if there's only one period in the file name. And for these examples, there's only going to be one file name. And we can actually then output the file name using sprintf. Update our file output name with our string up until the point of that dot as it's located. That can then be our file out name. We can then do this call that's actually going to take that image and run it as an output. We actually run this code. Let's give it a try. And we wrote image campus underscore r.png, but when we look at the default code, definitely should not have been the same value there. Campus underscore, let's take a look at the result again. Campus underscore r.png. That should be updated in our markdown file that's just showing the images that we have there. There we go. Okay. I guess I have to refresh it each time, which is a little frustrating if we're going to be using this markdown for it. But our example code right now doesn't do anything, so we no longer have our nice, pretty campus underscore r.png. Um, that's processing our input file name, generating an output file name. We're actually just, if we look at this function call, takes our image, GD image pointer, writes the result of it as a file called file out. That is our red channel file out that we have here. Let's actually try to grab that information and grab the red channel that we need. So going back up in our code now and looking at what our code is supposed to do. Well, first off, the prompt was enter name of file to invert. Well, that was the prompt from the first programming practice you're working on. Technically, we want to split into RGB. So let's actually improve our prompt. We grab our GD image type. We grab our metadata, and there's a function for everything. Grab our width, grab our height. It's going to print that out. We're not actually inverting the image. Now we're kind of splitting the image. And now we have our main loop. And this was not exactly a bug, but just as a starting point, for inverting the image, sometimes you only have to look at half the image, as you may see, because you're kind of moving one row to the next row. So you don't have to look at all the rows. You only have to look at half the rows. For this case, we want to look at every single pixel inside the image. So that's going to be our basic for loop that we have here, that we are taking our input image and we're grabbing the pixel at that location. So the correct function, and this is true, there's a correct function called GD image get true color picture that passes the image pointer, passes X, passes Y, and returns the pixel. Here we're actually just accessing the raw pointer, so that's fine. So we're going to access the raw pointer, image t pixels of yx. We then need to grab the red channel. What is the red information in our pixel? And it's correct to say that there is a function to do that, right? There's GD true color get red. Also, there's just a function in this file called, if we just look for red here, red is not going to be enough. It's going to be in that. It's in this one. This is the part of the problem, as I mentioned, that these functions all exist. You have to have a couple tabs open to see where it actually is. Is that documentation great? I don't know, right? It says there's GD image red that takes parameters. Image is the image. C is the color that it returns. It's a accessor macro, so it doesn't define it as a function. It's kind of ugly, but I think we can see that given a particular color as our input, we could define a color channel called red and use that GD image red. When in doubt, that header file, if we were to look at the definition for it, would tell us exactly what it's actually doing. And it's going to be bit masking of the individual things here. And it's actually calling GD true color get red, which is probably the right way to do it. And it's doing some bit masking where it's grabbing the individual bits. And it turns out that the red information is the most significant, or it's the third out of fourth bytes. We're going to mask it with an AND operator, shifting it to the right by 16. My hope for you as you look at this macro, which macros are ugly, but they get the job done, and you can kind of see what it's doing. It's a bitwise AND operator, not the logical AND operator, and then it's a shift to the right to give us the actual 8-bit value corresponding to the red here. You don't need to know that to be able to use that function, but you can look at the source code and see exactly what it's doing. And then we want to take that, and we actually want to allocate a color to be stored in an image where it's only going to be that particular image. So I need to declare, I think, another image to store the red information. Let's declare a second one right here. Let's call it image red. And there turns out that if we want to create just kind of like a copy of that particular image, there's a nice function that just clones the original image to start with. You don't need to do it this way, but if we have an image we've already read, the output is going to be the same exact size of the input size here. So we can actually grab our red information. We know how much the red is. We then need to actually update in the new image at X location, Y location. We can call this T pixel 2 or something like that, right? Which we haven't declared yet, which is going to be a new pixel using just that red channel information. And there's a function to allocate a pixel of a new color where you pass it the red the green, which is going to be 0, the blue for that new pixel. Uh, let's go back through this here. We iterate each column, each row. We grab the pixel at that location. We grab the red information only from that pixel. We create a new color for the new image that's only the red, 0 for the green, 0 for the blue, and then we set that in that. So we're close. Now when we're actually writing to our image, we don't actually want to write the original one back. We want to write that new one back, which is image_r, in which we are writing the red information there. So let's give it a try. We've written image campus_r for writing. And as we saw before, the image is probably updated, but the markdown maybe has to be refreshed to actually see it here. Sweet. And we got back to our red channel version. The version I'll post on Replit for you to check out will do red, will do green, will do blue. So you can actually check out all of those. But when in doubt, have the documentation open. Of course, always ask questions because it looks like with this library, there's 2 or 3 ways you can solve the same problem here. And when really in doubt, look at the source code of the library itself. Your structure is going to be pretty similar. Input image comes in. You may want to clone it to create a new output image. You want to do some string manipulation of the file name so you get a valid file name. It's going to look very similar to what I just did there, to be honest. And then you're going to want to do some processing as you iterate through that for loop. The tricky part, I think, is, of course, understanding a new library, working with functions you haven't seen at all before in this entire course, and then I guess getting it precisely right, because that's an artifact of our testing infrastructure that if 1 bit is off, the whole thing is considered wrong, and it's not easy to debug where 1 bit may be off. But if you get things visually looking correct, getting from there to a green checkbox in your testing for this mini project should be doable for all of these examples and should be, one very small change here or there. I believe in you. I'm really excited to see what kind of crazy, wrong looking images you come up with before you finally get it all working. And I really look forward to seeing your code and your results. So good luck. And of course, as always, reach out when you need any help with this project.